I apologize, Cassidy. I was so into this lesson that I forgot to start recording. So we went ahead and started. There are only 2 examples with this homework sheet. Example 1 we're going to do using Desmos. Example 2 we're going to use on your graphing calculator. So I'll show you how to do each one of those. Basically, we have a data set here, and we are trying to write an equation based upon this data set so that once I have that equation written down, I can like plop in years that I don't have to predict different values. I think we're talking about like the number of reported AIDS cases in the United States. Whoopee! From 1982 to 2000. So if I have an equation that fits this data pretty well, then I can plop in like 2001, what are the number of cases? 2018, what are the number of cases? Okay, so what I did first is instead of doing 1982, 1984, 1986 as my x coordinates, we said 0 corresponded to 1980, and then we went ahead with 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, and so on and so forth for the x's, okay? And so what you do is you go onto Desmos and you hit this plus sign here, and it allows you to insert a table. And so I went ahead and inserted a table, and I did all my x coordinates and I did all my y values, and you have to make very, very, very sure that you are not typing numbers in wrong, otherwise you will screw up the entire thing. And that is where we are now. Are you guys done typing? Beautiful, beautiful. Okay, so I'm going to zoom out so I can see where this stuff is located. Yeah. Oh, there's like one little tiny dot here. How can I get to be able to see all of that? Oh, no. That's only one dot.
Looks like they're all on this yeah.
It does look like they're on a straight line? Yeah. Oh, boy. Yeah, you zoom out, it looks like they're all sitting right there. Yikes. Okay. So here's what I want you to do instead. They actually don't sit on a straight line. Let's do this instead. Go to your, right here, to this little wrench up in the corner. We're going to change these axes right here. This is kind of like changing your window on your graphing calculator. So if we're trying to change our x's, what is the smallest x that we have? 2. So let's start it like a little beyond 2. Let's start at 0 on the x-axis, okay? And the largest x that we have is 20, so let's maybe go like 25. I don't know. Ooh, there we go. Now it's already a little bit better. On the y-axis, the smallest y that I have is 1,500. Let's go ahead and start that at 0. We'll start 0 on the y-axis. The largest one is 784,000, so let's go like 800,000. Okay, you see that? And it makes it super, super, super nice. Okay, I'm going to close out of this. So this is changing my window. It's a lot easier to change a window on Desmos than it is on your graphing calculator, right? Woo, super nice. Okay, so it kind of maybe looks a little bit linear, but not really. If we were to try to say calculator or computer, make me a linear function, what we would do is, I think I showed you this before, haven't I? What we do, if we want this to be a linear functions are y equals mx plus b, right? Okay, so I'm going to say y, but it's not going to know what I mean when it says y because this column is named y1 for some reason. So go ahead and type in y1. It will go ahead and automatically insert the subscript in there. And don't put equal signs. You want to put this like little tilde symbol, which is like shift the number that's right next to 1 on your keyboard, yeah? You want y1 is approximately, and let's do mx, but if we call it x, it's not going to know what I mean. It's putting a little like, what are you doing up there? That column is called x1, and let's do plus b. Plus b, okay? So if this data fit a linear function, my linear function would be, if I scroll down, my linear function would be y equals 49,399.8x plus this number, right? I like plop those 2 numbers back in there. Does that make sense? It's saying this is my equation with m and b being that, right? Now, to tell whether this fits very good, right? You guys can look at this line and say, well, a lot of those dots aren't on that line, right? This one fits pretty close, but a lot of those dots aren't on that line, right? Okay, look at your r squared value. Okay, r squared is 0.9, is that 3? 0.953. That's saying that 95% of my data is really pretty good. 95%, okay? Whatever, that's all right. 95% is okay. Let's see if we can get better than that, okay? We want that to be as close to 1 as possible or close to 100% as possible. So we start going up, and let's start doing like quadratic or cubic or quintic or quartic or any of those, okay? They want to, on our note sheet, they say find a quadratic, a cubic, and a quartic regression equation. Okay? So we're going to go down here again, and we're going to write a quadratic function. Okay? So we're still going to start with y1 is approximately. Now, what's my quadratic function going to look like? It's x to the second power, right? Okay? Yeah, let's write it ax squared plus bx plus c. Let's write it in that form. So ax, and make sure you put the x1 plus bx1 plus c. Okay? Now, what's that value? That's a quadratic function that's supposed to be fitting my line. Okay, so it gives me what a, b, and c would be if this was quadratic, but my r squared value is still at 95%. Let's see if we can make it better. Okay, can we do a cubic one? Let's go down and do cubic. y1, how do we make that cubic? Oh shoot, hold on, I didn't do squared. Blah. Are you guys like, what are you doing, Mrs. Comacher? There we go, that's better, that's better, that's better. Yeah, is that what you did? You're like, mine doesn't look like yours. That's why. I forgot my square on the next one. You hit shift, caret. Shift 6. Shift 6, and it does the 2. Okay? So that's at 98%. That's a little bit better. Right? A little bit better. And it tells me that a, b, and c would be this if that's a quadratic function. Let's see if we can get better than 98%. So we want a cubic function. So let's still do a, x1 to the third power. And now let's do plus bx1, x1 to the second power. Oh my lord. x1 to the second power plus cx1 plus d. Let's do that. That's my cubic function. Oh boy. Is that better yet? What percent is he at? 99.6 basically, 99.6. That's pretty darn close. Let's see if a quartic is better, okay? It wants me to do a quadratic, a cubic, and a quartic. Let's see if quartic is better. y1 approximately ax1 to the fourth plus bx1 to the third plus cx1 to the second plus dx1 plus e. That tells me what A, B, C, and D, and E are. Okay, what's that one at? Determine which equation best models the data. That's 99.8% down here. 99.8% of the data fits along that quadratic function. Now, let's see which one seems the most appropriate, though. Those are all of our graphs, right? Holy crap, that's a lot. Okay, linear is not good. Well, maybe. Quadratic is the one in red that I have up here. Yes. Okay. He's at 98%, whatever. The best one, the one that best fits the data is the quadratic function. But the quadratic function is the quartic function. The quartic one is the one that is in green. It fits the data the best. But if you notice, right as soon as I hit that last point, it goes back down again, right? So if I were to like plug in like 2018, it would probably be like a number all the way down here, right? Which is probably not realistic. So if we're going to use one of these functions to estimate further years, yeah, this one is the best one, but is it going to be the best if I continue it? Does that make sense? Probably not, right? So just according to what they were asking me here, find a quadratic, a cubic, a quartic regression equation and determine which equation best models the data. If they just say that, which one is the best? The quartic one. The quartic one is the best because it's at 98 or 99.8, right? 99.8% of my data fits that function, okay? So we need to write these in here. I'm going to go over here. My quadratic function. quadratic function is y equals a, it says, is 1758. X squared plus b is 9893.3. X minus 59024.3. 59024.3. Okay, that's that function. Do you guys see where I'm getting those numbers from? A, B, C, all the way over here. Yeah? Okay. My cubic function. Cubic function. Y equals negative 219.2 x cubed plus 9111.7 x squared minus 59991.8 x plus 103255. That's my cubic function. Okay, quartic, last one, is all the way down here at the bottom. A is negative 18.4 x to the fourth power plus 590.7 x to the third minus, does it give me an E? Hold on. Crap. Now it's better.
Why did they skip?
E is a number. E is like pi. It hated that. Yeah, it doesn't like that. You guys understand why that is? Yeah, it was using E as the number E. Okay, so this is going to change just ever so slightly. Negative 20.3 x to the fourth. Sorry, I didn't realize that. Plus 681.9 x to the third minus 4318.6 x squared plus 15550.8 x minus 17877.3. Yeah, we got to change that. Whoop. I'm not on my sheet anymore. There we go. There we go. That's what he looks like. Okay? And if we just go by the information that they give to me, the quartic function is the best, right? Because that is a 99.8%. The middle one was 99.6. And the quadratic function was 98.6, basically. Okay, so the quartic one is the best one. If we talk about predicting values, it's not going to be the best for long. Okay, good? What time do we get out of here? 20? 26. Okay. Go to graphing calculator. This one will be a little bit shorter because it's now got a lot. And this one just says, which one is the best? This one tells you, let x equals 0 correspond to 1950. Okay, so this is going to be 0. What's 1960 going to be? 10. I had a lot of people, I give you one like this to do on your test, and I remember last year, I think it was Bree, every bad thing happens to Bree, and then she bitches about it all the time. Anyway, she puts in 0, 1, 2, 3, 4, no, it's going by tens, right? So do 0, 10, because if they would throw in the year 1951, you'd be screwed, right? So 0, 10, 20, 30, 40, 50. Okay, we're going to plug these into the calculator, so I'm going to pull up my calculator here. Okay, and what you want to do is we put these under statistics. So you're going to go stat, edit. Where are you? Go back. Oh, you stupid thing. There we go. Stat, edit. On. The stat button is right below the delete key. Come on. On. Clear. Stat. Edit. Okay. I have stuff in there, so to clear them out, you go up to the heading and you hit clear, enter. I go over up to the heading, hit clear, enter. Okay. And now I'm going to start typing in my stuff. So 0, enter. 10, enter. 20, enter. 30, 40, 50, and that's all. 775, 357. I'll quit talking. Okay, so you get all of them typed in there? Maybe? Yeah? Okay, now, you hit the same button, stat again, but instead of going edit, you go over to calc, okay? And we go down. If we want a linear function, we hit linear regression. If we want a quadratic function, we hit quadratic regression, cubic regression, quartic regression, linear regression, whatever. Does it say which ones it wants us to do? Find a polynomial regression model that is a reasonably good fit. Okay, I went ahead and gave you the graph of what this looks like. What do you think? Should we try linear? No? Should we try quadratic? Linear's terrible. You've already tried it?
0.1.
Quadratic regression. We're going to try quadratic. Quadratic, it gives me my I squared. Oh, ooh, R squared is 0.88. Yikes, not good. Not good. So let's go back. I'm going to go cubic. R squared is 0.94. I'm getting better.
0.95 is.
Quartic. Quartic's the best. Quartic regression. 0.95. Okay. Scroll down, scroll down, scroll down. 0.95. Yep. That's probably as good as we're going to get. So we're going to go with quartic. Quartic regression. And we are going to say, it tells me A is something. I can't go. A, negative 0.107. We're going to go 3 decimals here. X to the 4th plus 13.19, let's go 200. X to the 3rd minus 387.244 x squared minus 168.648 x and plus 774,230.655. Holy crap. That is at 94%. That's as good as we're going to get. 95%. 95.4%. 0.5% is a quartic function. Okay? Now, it also asks the question, estimate the population of San Francisco in 1995. I'm not going to do that, but I'm going to tell you how to do that. 1995, do we plug 1995 in for X? That's not going to work. 1995, if we plug it in for X, we're going to get a really, really screwy number. Why? Because why? I don't want to plug 1995 in. Because I want to do 45. Because that's what I've changed my X's to. Does that make sense? What would 2004 be? 54. Okay? So you would plug those in and you can solve that, right? Okay? Good? No? What? Oh. I double checked everything already. Error. Okay, I'm gonna shut this off real quick.